Welcome to this session, Blockchain in the Flemish Government. Maybe a bit strange session that you have attended. Between all the geographical session, this might be another session that you attended. But I hope it will be inspiring and gives us also some kind of information and inspiration, of course, about using those kind of new technologies in your context. We have, for your release and for your comfort, not only given an introduction in blockchain, but also selected some cases that are a bit related with geographical information. So no worries that you won't have any geo information this time, but we have made some cases. Okay, my name is Daniel Duseuil. I'm program manager at the Flemish government in Information Flanders. And my task is, of course, as a program manager, coordinate all the different programs and projects that are within the Flemish government, but of course with our partners. I suppose this slide is not new to you. What is Information Flanders? What it does is we develop a coherent government-wide information policy to help and support and realize transition of government in Flanders. So our main focus was, on one time, more geographical, the ex-Agency for Geographic Information. We had a merge with the more government affair, and then we have a broader scope. But in that agency, we not only see what the geographical information is and what the different IT policies are, but we look also at new technologies, new emerging technologies, which we have concluded in what we call, it's here put in Dutch, but it's digital leadership track. There we look and experiment and research different emerging technologies like blockchain, like artificial intelligence, to see how they impact the government and the use and the interaction with the people. In that case, in those aspects is also written the blockchain program. Okay, in this session, which lasts 60 minutes of 90 minutes, we'll have focus on what is blockchain, of course, to have you up to speed from what that technology is. Maybe for some people it will be some kind of repeat of other session. I don't know, has anybody who wants to raise his hand and say he has already seen a blockchain presentation or introduction? Little minority. Sorry for those people. I will repeat these things. Maybe it's a good pedagogical thing to have it repeated. Then we'll see how it's implemented in the Flemish government. Why does a government need to look at the things? We have to focus that. And then on the most important part, we highlight a few cases. In the initial program, we had a few cases, 4 cases. We reduced that to 2 to have them more focused and more information. So my 2 colleagues will introduce those projects. Okay? If you have any pertinent questions during the presentation, please do. But at the end, we have also a Q&A. Okay? Okay, the first thing we start, of course, is you signed in for a session blockchain. Most people didn't know what it is, so let's introduce this concept. But first start with the quote. The quote is of Tim O'Reilly, founder and CEO of O'Reilly Media. And he states, and it's not applicable only to blockchain, but also to the other technology. He says that in every industry and every organization will have to transform itself in the next few years. He states that everything that is now coming is even bigger than the initial internet. So you need to understand it. You need to get on board. You need to see how it will transform your business. It's a more kind of call for action. It's all new, it's immature, but you have to see how it will implement and affect your business. It's going to transform it. And in that code and in that philosophy, also the government needs to look at those things and needs to know how it's going to be changing our world and, of course, our interaction with enterprises and citizens. Now, before we start and dig into what key concepts of the blockchain, I like to show you this image because it's a very interesting image, and it's also it gives us an idea how we look to new things. When they invented the automobile, of course, they came in the area where most people were driving horses and carriages and so on, and they saw this new thing. They didn't know what it was, and you get the reactions, yeah, but why do we need it? We can drive easily by horse and carriage. We don't need that. If you want to go from A to B, use a horse. We know how the horses work. We have all the infrastructure. We have all the stables and so on. Just use horse. And that's the first reaction that many people have when they see a new technology. They can compare to what they know and what they see and what they like or maybe are comfort with. Yeah? In the next stage, you see people, maybe that car is useful. Yeah? But let's combine it with all things. And then you get this kind of construction where you see how we have two technologies, the old one and the new one, and we have them it's nicely aligned. But of course, that is not useful. Yeah? You need to have the horse away from the car and let it drive it and let it make all the things. Yeah? And let it be fast, let it drive from A to B, but on a faster mode. But of course, with a new car, you have to have all the kind of infrastructure, all the kinds of new laws, and so on and so on. Yeah? So in new technology, the same thing. We invented the car, but this is not all the things, not all the traffic lights are, all the traffic laws are there in place to have it fully extend. Yeah? Keep this image in your head. When we advance at this presentation, you will see that the new concept, yeah, you need a new framework to pass them in. Now, of course, blockchain is a hype. You have heard maybe a lot of attention in the media from what the kind of solution is. It's going to change the world. It's going to be all the things that all the solution that came with blockchain was a kind of magical solution for everybody. That was mainly in those peak. Yeah? You see that is the Gartner hype cycle, and all new emerging technologies go to the same hype cycle. You go with innovation trigger, then an inflated peak of expectation. You see that all people are jumping at different firms, different solutions, different bad use cases. And then after that peak, you go down. And now we're going down. You see that a lot of use cases are skipped. A lot of disillusionment is now in place. I see that those technology is kind of reinterpreted. But that's a good thing. Yeah. See, we have a lot of use cases that are not interesting, and then we need to go here, where we go to the slope of enlightenment and the plateau of productivity. Yeah? So we're not there, yeah, but the technology is evolving. Yeah? Now you see a lot of people who said, yeah, I said to you so, blockchain is not going to use anything. So that's also in this conclusion, of in this thing. Now what is blockchain? I pointed here a definition. Of course, blockchain is related to Bitcoin. That's the only time I will be mentioning Bitcoin. Bitcoin is just one of the application of it. So don't look also at blockchain as an equivalent to cryptocurrencies. It's got nothing to do with that. Of course, something, but the implementation not. Yeah? And the definition that we have, yeah, it's a distributed ledger. I highlighted some of, you can read the definition later, but I will highlight the more key concept. It's distributed, it's a tamper-proof record of transactional data. So all the transactions, all the things that happen are tamper-proofed, recorded in a chain. Yeah? And the blockchain functions as a decentralized database. So you don't get a centralized system, you get a system that is distributed between different parties and between different organizations. Yeah? Each managed those things in a peer-to-peer network, and they keep a copy of the ledger all by themselves. You get different organizations that also don't trust each other, and there's also a key concept in this. You have different organizations, they want to work together, but they don't trust each other. And they don't want to hand it in the central organization. So how do you manage that? And then you get this concept where you distribute some kind of things. Everybody got a copy. Everybody knows who has the same copy and will look to the same thing. No? Trust is an essential thing, and it also includes, and there's more, we get more detail later, you have also smart contracts and self-authentication. You don't only register the transaction, you also register some kind of code that you can execute and distribute yourself. Huh? So that's the main definition, but the terms you have to remember in this technology are written here. It's about transparency. You share a certain database between all concurrent, the rivals or competing firms or organizations that doesn't trust each other, but we look at the same records. We look at the same thing. It's about decentralization, not installing one party that controls everything like a government, like a bank, that all has all the records. No, we have to decentralize it, distribute them to different networks. Yeah? So no one has control. It's about immutability, and that's a very key concept. When you write something to a blockchain, it's there forever. You don't have the possibility, like in database, I change something, nobody knows it, and that's the truth. Yeah? No, you have an immutable records of all the things that have happened. Yeah? It's about trust, it's about assets, but it's mainly about collaboration. You don't use a blockchain when you're alone. We have some use cases that were focused there. We had the Flemish government, we have an agency, and now we need a certain blockchain for our own. Yeah? That's not a use case, because you have to have that decentralized factor. You have to have many parties looking at it. So collaboration is the essential part, but it's also the difficult part, because you have to agree with different competing services and competing organizations. Yeah? You will see in the cases that we present and the cases that we are just informing, yeah, we try to work with consortium to try to do with network. Yeah? And that's 90% of the work that we are doing, is seeing how those networks and how those consortium are being formed, and technology is following. Yeah? Okay, before we start with the different terms that we have, maybe a key concept of the blockchain is the hashing of information. Yeah? So in hashing, you have two kinds of, very simplistically said, two kinds of things. You have the encryption and decryption part. You have certain piece of information. You encrypt that with a certain key, an algorithmic key, mathematical transformation. And then you have the possibility with an other key to decrypt it. Yeah? That's the most easy way. You have the two-way. But in blockchain, we use a variant, and it's called the hash. We have a kind of information. You put in a certain algorithmic transformation, and you get it an hash text. Yeah? That hash text can be between 50 or 200 characters long, but it's unique for that piece of information. Yeah? And that's also very interesting. It's one way, so maybe you see what's the use, because you go get from B to A. But if you see B, you can check, yeah, if A is the thing, the real information. I have a document, very restricted, sensitive, or maybe a document that I need to share. I put it in a hash, and so I can give to another informant of another recipient that kind of information. You can check it that it hasn't changed, compare it with the key. Yeah? And the people who has the formula or the hash function can check the document and check, do I have the same hashtag? Huh? And blockchain is also, in that kind of information, you had information, they always use the hash to compare, has the information been changed or not? And that is what the way more technical that blockchain is written. You have the different blocks of information. So every piece of information is written in block and is always related with the previous block. So you had the hash key we were talking about. So you put all the information, you calculate the hash, you get that. But they also include the previous hash. And they do that in every block. Huh? Why do we do that? So imagine that I want to change this block. Yeah? I put I change some records, I see some text, I state that my subsidy is not 100 euros, but 3,000 euros. Yeah? Then, if you recalculate it hash, yeah, you can have a different hash. That changing of the 100 euro to 3,000 euro gives you a different hash. Yeah? The hash is something else, and it's not equivalent to this hash. So you get an error. Yeah? This error goes on here, and here, and here, and here. So you get everything that you try to change, you're going to need to go backwards. Huh? In the database, it's another question. You change a record, and nobody knows about it. Huh? In this system, it's not possible. You have to change all the chain to have something changed. So it's in that way immutable that it's always related to the different information. Yeah? That's a nice thing, but you have to combine it with the decentralized thing. Yeah? So in the blockchain governance, in the classical thing, let me say that first, you have different organizations, they all relate to the central database where they store all the information. Yeah? And if you want to see what is in the database, you will check those central things. Yeah? The central authority has a lot of power about the information. The other are just seeing what is included. Yeah? And the other models, yeah, you don't go with the information, you don't go with central place, yeah? You store and distribute that information. So if anybody wants to change that chain that I mentioned a few minutes ago, you need to change all the copies that are distributed in the network. Yeah? And the model we use the most is model 3, because we have there a private network. You agree which parties have a copy of that information and which parties can participate in the network. Yeah? In the middle model, you have, like Bitcoin, everybody can participate, everybody can share the information. And in that model, you have those 6 organizations who share those ledger. Yeah? And the information is shared between them. And no organization can change it because they can change their own copy, but they can change the other copies that are in the 5 other organizations. And that's a kind of model of trust that they use. Yeah? You have the immutable ledger, and you share it, so that's a double proof that nothing gets tampered. Yeah? You have, of course, transparency. You see what is written in that blockchain. You see what has been changed, what has been added. Yeah? So we had a database that's constantly made of transaction and made of things that can be seen and can be checked by the different aspects. This is an example of how Bitcoin works. All the transfers of money can be checked here, yeah? And it's widely open. Yeah? It's not only about transactions, seeing how things are recorded, but you can also share code, and smart contracts, as they be called. Yeah? You put on that distributed thing and that distributed database also the code. And you can have a certain parameter, say, if this happens, execute that code in those different settings. Yeah? And that's an example that my colleague Yannick also will tell. If we work with subsidies, it will be very interesting. You have the parameters of subsidy written in a code that is distributed in the network. Yeah? So everybody sees what kind of parameters there are. If I want to have a subsidy for my nature management plan, what are the rules? And those rules are shared. So you have another step than only having the transactions shared, but also having the code shared. And that's very interesting for our government. If we have all our agreements, all our services written in shared services that can be distributed, we have an advantage, and we have a possibility to have the stakeholders also involved in our network. Now, also, a big important thing in blockchain is the possibility to share an administrated digital object. Because in the classical web, if you have an image, you have a document, and you want it not to be duplicated, it's very difficult. Yeah? If I send you a file with a picture and say it's my picture, you can make a copy of it, and you have two pictures of 2 things. Yeah? Those digital objects are very difficultly being unique. Yeah? You can copy that. Now, with an image, that is not a kind of big problem, but if you start with digital money or digital value assets, they can be multiplied. Huh? If I give you 50 euros or 50 bitcoins, and you make a copy, we have 100 bitcoins, you make another copy, you have 200 bitcoins, and so on and so on. So you need a system that an asset is individual and uniquely digitally available. Yeah? And that is in the blockchain acquired by also, distributed. We see that object can not be copied, but if we transfer it from one side to another side, that transaction is recorded, and if user A gives it to user B, user A doesn't get the possibility to make a copy. Yeah? And we see that it's now in the propriety of the user B and cannot be shared with cannot be duplicated. So you get an individual record that can be in a kind of way all the records for the transaction are shared and are distributed. And that's an important concept because in the government we manage a lot of assets of value, and how can we manage them between different organizations. Yeah? We have traffic assets that we share. Yeah? We want to know that asset is not multiplied and not doubled in certain records. Okay, the trust is of course one term that is also very important. Normally, if we don't, if organization 1 doesn't trust organization 2, what do? Classically, we put a trusted authority in that. Yeah? If I give you the money and you will send me the goods, but I don't trust you, yeah, we have the other party that collects those 2 items and then we distribute it. Yeah? That costs a lot of money to establish this thing. Yeah? So we have another model where the network does the work of decentralized authority. Yeah? We share things, we share assets, we put transaction there, but the network will handle those things. Yeah? And of course, if I can quote Peter Hinson therein, yeah, the network has always more power than the individual or the central authority or the middleman. Yeah? And that's also the power of blockchain, to have that power of the network we used for settle things, keep records of transaction. Now, if you see what use cases are now emerging in blockchain, we see, of course, in many sectors, very different cases. The most important case of the famous case is a case of here in the port of Antwerp and also in Rotterdam and all the other ports, where we want to keep track of the supply chain of containers. A container goes from China to Antwerp, goes by many, many hands. And the one thing that is now being used is just a paper. That paper can be duplicated. That paper can be altered. It can be changed. And nobody knows how to keep record of this. And there are many, many different firms that are handling that document. So you don't kind of solve this with one central database where everybody looks and everybody writes, because you have very competing organization. Yeah? They don't want to have one super user that knows everything. So you need some kind of distributed trust, and that's introduced by the blockchain. Yeah? The container is a kind of way virtualized, and that virtualized item is handled by a different one. And it's go from port in Shanghai to the ship, then that the digital thing is transferred to the ship. When the ship goes to the port of Antwerp, then it's handled, and then go to other. Yeah? So you get a proof of records of all the things that happen with the container. Yeah? Not only in containers, but also in online tickets. People who have go to concerts, they know this. You buy a ticket, yeah, or you buy it second hand or whatever in the market. Yeah? And so certainly by digital objects, like it is an online ticket, it can be copied. So maybe one people that has stolen your ticket, yeah, can go in your place and then you get a message, your ticket that's also be used. Yeah? So how can we solve that problem, that tickets are unique and not being copied, yeah? And can also be transferred. Because most people forgot, but as a consumer, you have the right, if you buy something, to resell it. Yeah? And that reselling is very difficult because you have a lot of fraud in that. But if you can sell the transfer the unique key that you have with your ticket, yeah, then you don't have the danger that it's been duplicated or been lost or whatsoever. And you keep also track of it. Yeah? And you can have also rules, yeah, that you don't buy tickets of hundreds of tickets, of thousands of tickets, and then sell it for 25 times the price. Yeah, you can have with the smart contract rules that you can alter those things. Yeah, banks are also looking at it. We have the WeTrade example, where 8 banks try to solve together, yeah, a problem. If a small company, an SME here in Belgium, wants to buy wine, as an example, in Portugal, he doesn't know that wine producer. So how do you establish that trust? Yeah? How do you see that record, the transfer of goods and transfer of money is settled? Yeah? So they want to lighten up the chain. They don't want to have 50 people involved in the process, where they check, is the wine arrived, has the money been sent, and so on, has it been settled, because that it has a big influence in the price. But how you see the network works and arrange them itself and keep the trust. Yeah? Of course, with blockchain, there are a lot of risks and challenges, of course. Yeah? We as a central partner, as a government, we like to initiate this blockchain, but it's a little difficult to have the decentralized item initiated from a central partner. So you see that we have control many things. In Flanders, we have tradition to have a centralized working, yeah? But then we promote decentralized working, and that's not always very easy. We have, of course, a lot of issues with GDPR. Yeah? It's very interesting that you have transparency, that you have immutability, but how do you rhyme that with the right to be forgotten, yeah? With the right of anonymity, and so on. Yeah? So personal information and sensitive information, yeah, it's very difficult to put them that right away in the blockchain. So you need to have that kind of challenge. Of course, ecological footprint is also important, but as a comfort of a relief, the things that we are looking at, the private blockchains, are not that big influenced. Yeah? It's mainly the public blockchains that use a lot of energy to calculate the hash and so on. Yeah? In our case, it's not that important. Yeah? The findings of transition, we go to another business model. Yeah? Many people, partners, yeah, and maybe the example that Yannick will do, we include other parties, other organizations. Yeah? If you decentralize the model, you have some cost with the other partners too. Yeah? Who's going to pay for that? Yeah? The maturity of technology is also a big issue. It's a very young technology, very promising, but it's young and immature. Yeah? You have to handle. And the right case for blockchain is something that we need to learn also. You have a lot of cases that are thrown in it, but are not the right cases. Yeah? Now, don't let those risks and challenges be afraid. I'm not that big of Microsoft fan, but if we can really use a code, it's also, there's always underestimated change. We occur the next 2 years. Yeah, we all see that also is bigger and bigger. We see something new which is going to change our life in 1 year or in 2 years. Yeah, yeah. So we see that also is overestimated, but we underestimate the change that will be in 10 years. Yeah? Because that is a constant. Yeah? Now, don't let yourself be lulled into inaction. So it's not because it's not going to happen in the next 2 years. It will be happening in the next 10 years. So you need to come in action. Yeah? And see how it works. Now, those are the more general explication about your blockchain. Why do we need it? How do we work in the Flemish government with it? Yeah? We work with and we different tracks. We have the blockchain services that we are working at. Yeah? That we don't have to reinvent in every project the same thing. Yeah? We have the project, blockchain project, of course, and we have a kind of promotion. Yeah? We need that a lot of work has to be done, discussed about how can blockchain be working. Yeah? Now, why we look at the blockchain? Blockchain in the Flemish government, mainly of 5 reasons. Yeah? 5 reasons that we see in the other things, of course. We as a government need to be transparent in everything that we do. Yeah? That we own that to our citizens and our corporation, that everything that we do, all the assets, all the subsidies, all the money, and all the power that we have, that's be transparent. Yeah? That you see what the government does with your money. Yeah? We see it, of course, as another model to work with the different stakeholders. Yeah? Flemish government wants to be an open government, want a government that interacts and works together with different partners. So we are involving the decentralization and to partnership. Yeah? We don't want to do it always ourselves. We don't want to be always the central database, the central system. We need to have it in another way. Autonomy is also important. Blockchain has the promise that it will give the right of the ownership from certain assets back to the citizens, back to the corporations. Yeah? As an example, the diplomas you have in Flanders are stored in the LET database, the learning and the diplomas database. Yeah? We store them for you. You as the owner don't own them and don't have them. Yeah? So we need to go to another model where you as a citizen, it's your diploma, you earned it, that you have access to it. And if you want to share that diploma with the authenticity of the university, that you have the possibility to do it. And now the case, that's not. Yeah? If you want to share, give access to my diploma from the data bank to another organization, that needs to be done by the government. You don't have the sole autonomy to do that. Yeah? And of course, smart subsidies are important. You will see that in the case of the nature management, yeah? Where we have certain rules to give money for certain grants. We need to get that more transparency and more automated. Yeah? Now, if you look at blockchain and the different projects, then it's very interesting to look at this picture. That is what people actually expect of the technology. Yeah? If all those nice kind of features you have, you expect a fully controlled thing, a fully controlled airplane with everything arranged, automatic pilot, extra security, and so on, and a pleasant journey. Yeah? Of course, you can imagine this is what the reality is in blockchain land. Huh? It's exciting, you can fly, but technology is nowhere. Yeah? Be brave, if you are brave, you can jump in, but we can crash. So the pilots that we have were brave people who thought on, I have an idea, I have something that we try out, and we risk it. So that's today technology. It will evolve to this, but if you are more comfortable with this, wait a few years, but if you dare this, come in and jump on board. Okay. Now, blockchain, of course, and those projects that Yannick and Joris will share with you in a few moments, it's just a piece of the puzzle. Yeah? In most cases, it's 5 to 10% of the application. You see that a blockchain application doesn't exist. It's just one layer of your application. A trust layer, if I can mention it, but not the only thing. You have a lot of technology revolving around that. Oh, oops, there's a double one. Okay. Now, what are the projects that we are now actively supporting, researching, producing? Yeah? There's a few mention of them. Yeah? We are building the local decisions as linked into open data. We are building nature management plan that will be shared by you. We are working on a European level on international exchange of diplomas. We are exploring Validata. There's the information about corporations and enterprises, international waste transport. We are working at self-sovereign identity, give the control back to the citizen about this data. The building pass, I don't know, is that a good English word for that? Yeah, okay, will be checked by Joris. And then traffic asset management, Other trail about building permits. Yeah, we have them in Belgium, building permits, and we want to keep track of them. And a permit registry where we keep all the registry that are handed in. If you have a building permit, we're going to check it and we can have the authenticate things. Yeah? So we have a lot of interest, and all those projects are made in collaboration with other partners. Yeah? So not only those things that the Flemish government is working, and then when it's ready, we're going outside. No, those projects need to be collaborated with other people. Okay, and now another code to conclude my kind of presentation. It's coming together is a beginning, keeping together is progress, and working together is success. And in blockchain, it's the key concept. Yeah? You don't work alone in a blockchain, you work with partners. And you have to arrange and agree with those partners to make it a success. Yeah? It's it is not a project can be built in your basement or in your garage. It's going to be outside. Yeah? Okay. That's my part of the presentation. I'll give you a brief overview. I will hand the word and the micro to Yannick. Yeah, of Joris. I don't know who's going to start. Yeah, okay.
All right, good morning, everyone. I'm Yannick. I'm a business analyst and project manager at Kunstmaan Accenture Interactive. And together with the Flemish government, the Agency for Nature and Forest, Informatie Vlaanderen, we did this prototype application for nature and forest management in Flanders, and looked into the ways of using blockchain and making it more transparent and finding ways of maximizing the ecological, social, and economic value of nature in Flanders. Okay, yeah, not to the screen. So I went too fast. Okay, so I want to start with the fact that I think everybody finds nature important. For example, I love to do walks in the weekend with my dog in woods, and I think everyone has a relationship, but it's fragile, became fragile along the way. The way we, as a community, start organizing with it is making governments responsible for managing this nature in woods and parks close by. There is, I'm sorry, I'm a little bit nervous, always when I talk, I need to cool down a little bit. But it's a very administrative process today. When you go to the Flemish government, you need to fill in nature management plans, which is a lot of paperwork. When you need to start a nature reserve, it's an engagement that you do for 24 years, but there is a lot of study work going in front of it, a lot of drawing in plans, seeing how nature will evolve, stuff like that, which is very important, but it's all done on paper. It's very intensive for the administration too, so the Agency for Nature and Forest too, to study the work and see how the subsidy settlement can be done. So this is also a case a little bit for digitalization, I think, but we've tried to find a way to make it more distributed, to see how the parties in the nature ecosystem, for example, nature managers, also get a little bit more responsibility. Is it too hard? Okay, a little bit more responsibility for the engagement that they are going to do for the next 25, 24 years. And that's why I say today they have to go to their desk and fill a lot of paperwork, but actually when we have these digital tools, they can be in their working environments and doing the work that they do in the environment that they love. How did we start this proof of concept and try to put in the fundamentals of this case? And there are 5 things that I'm going to try to talk you through before I explain what we exactly built. the thing of giving a geographical contour an active identity or a digital identity. And I see there are a lot of geo people, so I think we can discuss this a little bit more. But the idea of identity and giving identity to a geographical contour is something that we like to introduce here, so that we can create interaction with this geographical contour between individuals, but also between these geographical contours themselves, or in a later phase, for example, with IoT devices, smart meters, drones, stuff like that. So you can get signal functions from a smart meter saying, you need to mow your grass, for example. And it's going directly to the geographical contour, which gives a signal function again to a nature maintainer. So, and then all these transactions are stored in the blockchain, and you can really get a good view and a history of this geographical contour and see what's the evolution of it. The second part that we try to put into the application, and that's something that Daniel already mentioned, because it's about subsidy settlement, we saw that a lot of work, and I already said it, a lot of work goes into looking into the paperwork, see if everything is all right, every paper is there, but every time you need to ask a subsidy, you give a lot of the same information. So when we digitalize it, for example, address stuff, but also what kind of nature is this, and what's the goal of this nature type that I want, you can just register those facts, and based on that, we can create automated rules to calculate the subsidies that you own based on, for example, how big the contour is and what kind of nature type it is. So that's one thing. And the second thing in this automation that we saw is to make it a little bit more transparent. We introduced a digital token. It's nothing to do with cryptocurrency. It's a digital token, which is a euro-backed digital token. It's just to make it more transparent of where the money flows and how it goes. And we can put some rules on this token. So, for example, when I have a contour which is right now a forest and I want to make it a heath, I will get subsidies for that. For this, I don't know what. Okay, so I will get subsidies for that. But this digital token, because it's digital and we have this identity of the geographical contours, we don't pay the money to an owner or a nature manager, but we pay the money to the geographical contour. So that's also a new aspect. So it will get clearer a little bit later. What is also important is, and I think I mentioned already this, is the traceable history, the evolution of nature. We can see all the certificates of all the actors in the system, owners, nature managers, and we can also see how the subsidy flows from the wallets into the system. And we also created a single source of truth, and that's all. I think something that's already mentioned, but there is just one source where you go to see how is it going with the nature in Flanders, and that's our blockchain. And all the actors are working together on this source. And all the data is real time, so that's also, I think, a good aspect. I'm quickly going over this. What's also important when you implement blockchain is to think about user experience, see how different roles in the system work, and try to maximize the power of blockchain, bringing transparency and trust into the system. So what I'm going to show you now, so this is the 5 things that we wanted to test, is I'm going to quickly go over with you through the flows, so what we created in the prototype application. We have 4 actors. You have a landowner, which can be a government, but also private owners. You have a maintainer, which can be nature organizations or individuals themselves. You have a contractor who do the mowing and stuff like that. And then you have the approver, which are people from the Agency for Nature and Forest. We've created a few objects. So you have these contours. You have a land contour, which is in the system. You have the nature management plan contours. And then you have also the nature type contours. Within the nature management plan, for example, there are forests, there are heaths, so that's a nature type contours. And then we also have subsidy contracts, work contracts, and then of course the coin. It's not readable, I think. Doesn't matter. You have actually 3 parts in this flow. I'm quickly going to go through it. I'm not going to take every step of it. But the first step is creating a management plan. The owner there selects a contour, assigns it to a maintainer, and the maintainer can start making observations. For example, this is a special species of plant. This is forest, so he can do it there. That's what we did there. Then, when a maintainer adds a goal to a nature management plan, there is automatically a subsidy contract created, which then can be approved by the Agency for Nature and Forest, and then the digital token gets into the system, and you get a monthly subsidy on your nature type contour. The work contracts, it's about the contract between a maintainer and a contractor for managing the land. The work contract makes sure that the contractor at the end gets his money for the work that he's doing in nature and in the forest. I have a small movie made of the demo application. I'm quickly gonna play it for you. I'm not really gonna go much into detail of every step because it's a movie of 7 minutes. I think it's too long, and maybe you have questions about it. But we have created actually a dashboard for these 4 actors that you saw in the beginning. And so what you see here is the functional front end, which is connecting with the blockchain every time. So here we are creating a nature management plan. I'm sorry, it's a Dutch interface, so here it says, okay, I want this maintainer to manage this nature management plan, and I'm giving this amount of money every month to him. And actually, what you see there happening, it takes a lot of time to validate it because every time, for example, when I create a nature management plan, he's going to see if it's intersecting with another nature management plan, sees which kind of owners do I need to ask permission to join the nature management plan, because in Flanders, nature management plan can be part of different owners. So it's actually stuff like that which happens here and which takes a lot of time to get validated, because every time the blockchain needs to be consulted for this. Maybe quickly. Okay. I wanted to skip a little bit in the movie, but I went to the next slide, but that's okay, I think. So maybe a little bit about the blockchain part. We've built this on Hyperledger Fabric, which is an open source blockchain platform under the Linux Foundation, built from IBM. It's really built for enterprises and organizations. It's very modular, but like every other blockchain platform today it's very and there is a lot of evolution in it. It changes a lot. There are a lot of new versions. So for example, we built it in version 0.1, but by now I think it's 1.2 already with private data possibilities, stuff like that. But what was really interesting and so maybe I'm going to add also a thing about Hyperledger is the databases behind it. It's not really suitable for geographical calculations and stuff like that. This was really a challenge, I think, to build it. But I think maybe in later versions we can integrate maybe with other databases to see what are possibilities there, or create oracles into the blockchain consulting geographical databases. The interesting thing, and I'm going to highlight a few things here, is in Hyperledger you can create channels. So we have a public channel with 2 nodes, which can be consulted through applications for citizens, owners, stuff like that. But you also have the private channel, and the private channel is an interesting part about Hyperledger. Is you create actually some kind of blockchain within a blockchain, where we can handle private data. So every data about landowners, which is actually private data, we store it into this private channel. So it's not consultable for other parties into the ecosystem. On the right, we have a certificate tree, which is actually the chain of trust, let's say, which gives authorization to different parties into the system accessing to some kind of data. So I'm not going too much into detail. What we also created next to the network setup is a lot of chain code. We've created in total 9 chain codes. Actually, what's also important, what I'm going to say here, is that everything is open source. So the network that we created is deployable on AWS with three different. We've set it up with 3 different virtual machines, but also the chain code that we created is available, and yeah, you can download it. Voila. So that's mainly what I wanted to say.
All right. Hello, everyone. I'm Joris Hogeboom, and I'm a blockchain analyst developer working at POW. And for the AIV, Agentschap Informatie Vlaanderen, we're exploring now what blockchain or distributed ledger technology can do for woningpas. And in this case, I did not translate it into housingpas. Wasn't sure if that's the right translation. Just kept it as a Dutch, sorry for the Dutch term here. So there's a couple of things I'm going to try to explain to you, because both the woningpas is a new thing and the blockchain application that we're exploring for this woningpas. So I'm going to introduce woningpas, then say what blockchain use cases we're looking at for that. And then I'm going to give a short demo that has been built by students. So first, the woningpas. Why do we have the woningpas? This is a new development. Who of you here is a homeowner? Who of you has a very clear idea about all at the stations of your house when you need to move? Do you have your whole administration completely in order? No. One hand. Okay, very good. So the reason why woningpas exists is to give homeowners a very clear idea about the data that the government has on your house, and this is related to a lot of different aspects. This is about the energy performance of your house. This is about documents relating to whether you have permits, whether some checkup has been done, the state of installations, whether your heating installation is still okay, what is the last checkup, the complete history of this house, and also, of course, geo information. Where is it located? What is the land contour of your building? So the idea that all this information now reside in different government databases, and the idea of woningpas is to present a unified interface for the end user, so that it becomes clear to understand what this means for your home. So when you have a home, you would log into this woningpas. You would see, okay, that's my home. I live on this Ferdinand Loesbergkai in Ghent. You click on it. You're presented with this interface where you can traverse all this information, and some of this information has already been digested for you as a kind of reminder, or as a trigger for action. For example, if your installation is not up to snuff, you can be triggered to improve your energy performance. So it acts as a portal for your house. Also, there's geo information. What neighborhood is your house in? What is your house in a flood-prone area? Because that's an important thing for when you have to transfer ownership of your house. It has certain ramifications. The energy performance. The idea is that it recommends actions to users. So if this is, for example, an idea of what would the solar potential be of your house. If you would put solar panels on your roof, is that a good thing for your house? And eventually, when you want to sell your house, it presents an overview of what documents do you all need to provide to make this happen. And these documents, that's something that I'm going to continue on, because that will be the basis for the blockchain application. Because woningpas is still in development. There are a couple of things that they're focusing on for creating this year, for creating next year. But already we have to look forward to what do we want to have in the future. Because right now, as I explained it, woningpas is a kind of a view on data that's already known at the government. So it's kind of a passive identity of the house. And what we're looking for is, how can we give this house an active identity? How can we make the user or the house owner also take actions as quickly as viewing the data without going through the same kind of paperwork? So what we want to achieve with this blockchain application is now a lot of these attestations and documents that you need to provide when you move, for example, they exist only in paper form. Some of them, for example, here you can see some of them, they are known at the government, they are already provided, but a lot of them are not known, they're not centrally gathered at the government. So the idea is we want to give the user the ability to upload these documents to their woningpas, and from there be able to share it with other parties, like the government, like a contractor that does work on your house, so he can see what is the state of your heating installation. But also, if you want to sell your house or rent your house, what is the state of your house? When was the last checkup? Are there no hidden faults in the building? And eventually build up a body of records or a history of the house, so that when you transfer the house to its new owner, not all of these paper stacks are, now you have to kind of give a briefcase maybe with all the information to the next owner. Now we want to build up this information system so that when you transfer it, this information is attributed to the house and it travels with it. So why use blockchain for this? Why not build this as I said, uploading documents, that's something that we've heard before, it's something that web servers can do. And I'm going a bit to the part Daniel also talked about. It has to do with what kind of role do we want as a government? Do we want to build this service and that the government has to store all these documents for all eternity? Maybe that's not a real plausible model. So how can we look at one, users being in control of their own data? Now they have control over the data in paper form. We also want to give that in a digital form. Also, government maybe should not store all this data. This is how can we make how can we work together with different parties, build build a platform that many different parties can interact with. So I think the challenge here is in facilitating that digitalization change and not developing it at the government and then owning that. So for that, I'm going to introduce a little blockchain concept, because later I'm going to transform this to the house. This might be a bit much. I'm going to, bear with me. Who has heard of this concept of a self-sovereign identity? Nope. All right. So the idea is now an identity is given to you by the government, for example, or by a federation. Let's say you have a driver's license. This number, they are given out by the instance that governs the driver's licenses. It has a set of attributes. When you got the driver's license, maybe your date, what kind of vehicles you're allowed to drive. The idea of a self-sovereign identity is that this license number that is given out by this department, it's not constrained. You can make an empty identity, and you don't need to ask permission for that. But instead, you fill it with attributes later. So what you do is you create an identity on the blockchain. It has nothing, and you get a little claim that says, a little piece of information that says, okay, I'm allowed to drive, or this is my age. So this can be done for persons to help facilitate interactions with government. But what if we apply this to a house? So some of these, the idea is here that you have an identity as a person, and you have an identity of the house. As a current homeowner, you have this is mediated by the ledger technology. You are allowed to act on behalf of the house because you currently own it, and you gather little pieces of evidence. Like, for example, you did a certain type of renovation. So this constructor, he will give you a digital proof that you did a certain renovation, and it attached to the house identity, so that whenever you transfer the ownership of the house, it is also you no longer have access to things that are not related to you, but are related to the house, and the next owner can get insight into all this information. So because the thing is, the reason why we do this is this allows kind of data minimization. When you have a driver's license, all this information is put together, and the way that it's tamper-proof is because it's in a certain type of plastic with a shiny surface, and it's hard to remake that. But this does not apply to digital. We can make a little piece of digital information that we can verify or prove that it has not been tampered with, and that it has been signed by a certain authority, like a contractor that did a piece of work. And you only have to share that information with whatever party you choose. So you don't have to share the whole database of your house in order to get a subsidy on just a certain kind of renovation. And so that's about the general concepts. So how does this apply to, let's say, a real world use case? So we've identified two kind of issues. One is a lot of these data comes from government sources. They are of course trusted because they're in government databases. However, how can we validate all these paper documents and use them as proof for other workflows? The other thing is some parts are in government databases, but the government database is not allowed to exchange them. This is one of the part of the woningpas. You might not, just by using the woningpas, you don't want to give authority for other departments to use that data. So you want to be in control. So these are the two use cases. One is we pick one of the paper documents. We have it validated by the constructor, and then we have a kind of digital proof that we can record in this active identity of the woningpas and use it to facilitate interactions. The other thing is it's a lot of work now to get a subsidy for doing a kind of renovation. Some renovations they are subsidized, but you still need to go through a paper administration process. So we look at how can these claims, how can these digital attestations make this quicker for the user automatically. One of these use cases we've explored in a proof of concept. This is done by students of the Open Summer of Code. It's a kind of summer week or summer project where in a month computer science students, they do kind of interesting projects, and woningpas was one of their projects. And in this project, they took one of the it's a keuringsrapport. It's a checkup of your installation, and they implemented a flow where you can upload this to your woningpas, have the inspector validate it, and then have a validated document that you can store in the woningpas. So I'm gonna now walk through a little bit of this demo. This is a live demo. It's always very exciting. I hope this is promising. Let's see if we can. All right. So the idea is, I'm owner one. I'm gonna log in. This is one of my houses. They look exactly the same, which is something that I still need to fix. So okay. So we currently have no documents. What if we want to add this this keuringsrapport? So we have it here. We will upload it. It will take a while because it's being recorded on the blockchain, or the hash of it at least. All right, so we get back that this was recorded, and it says not verified because we got this PDF from the inspector, but he didn't actually. We could have just changed a couple numbers or did anything with it. So just uploading it doesn't prove anything. We need to have this inspector look at it again and say, okay, I sign off on this. This is what I put on paper. So we have it as a link for the inspector. We're gonna copy it to the clipboard. And go here. Oh, should log out. Okay, so we're gonna log into the inspector part, and then hopefully this works. All right, so we're presented now with a request to sign, basically. We can view this. We can download it again. So yeah, it's pretty empty. We didn't really fill it, but in reality, you would have filled it. So okay, we agree. This is what we inspected. We validated. This is also going to take a while. So now, as inspector, we have verified this document. I'll log out. So when we see our house now again on the in the woningpas, we can see, okay, this inspector has indeed validated our heating report, and this is now in our woningpas and ready to be transferred also to future homeowners. And this is all I wanted to say today.
Just information. So is this running on just a public blockchain in general, or is it a private blockchain?
So in this case, this is running on a private blockchain. And I have to say, there's a difference. For this proof of concept, we made a couple of abstractions. So this is kind of a simplified version of the actual thing you would put in production. But for the sake of not giving away the data, it's important to, in this case, to keep it as a private blockchain.
Now, maybe mentioning, as Joris also mentioned, it's a proof of concept. It's an inspiration for the next government declaration and government policy. So we see that as Joris mentioned, we have the steps and the development in this year, the next year, but past 2019, 2020, we need to look at it in a different way. So this track is merely an inspiration track, and the technical choices will be different.
Thank you. That was a very interesting presentation, specifically about the woningpas. With all the documents in one place, I can see a lot of benefits from having all kinds of services now making all kinds of services possible. Mm-hmm. But how about the business impact? Has anybody been looking at potential savings yet, or the business implications of an implementation such as this one?
I think a lot of the implication is that, or I think it could be a reduction in administration costs. So things that now take a whole while to process because someone needs to look at a PDF. These things can go much faster if you have this digital attestation that can be pretty much automatically processed by an API, for example. So I think there's going to be, I think the business implications are around that. There's cost savings for administration, but it's also for the homeowner to be able, it's ease of use. It is easier to trigger. It might
not calculated at this moment.
Yes, no, sorry, that's what
No,
okay.
Well, I work with the Open Geospatial Consortium, OGC, and we have recently created a domain working group about blockchain. And I would like to know if you identify some clear needs of standardization related to geospatial applications. Yeah, we have created within the OGC a working group to discuss about the needs, and it's as an open forum to discuss about the needs in terms of standards. Do you identify already some clear needs of standardization for geospatial applications?
Now, maybe I ask, and Yannick and Joris will answer. It's a bit early for a big standardization. We have the first concept, first tries, first step to production. And we'll look at standards at an ISO level, see what kind of blockchain standards are emerging. I see a lot of evolution in the systems. Yeah, so it's very difficult to say right now what kind of standards are being needed and what kind of direction are good. Is now merely looking at definitions or global concepts, not on the technical standards. Yeah? And also, if we make the bridge to the geographical information, those two kind of projects are the first thing that we touch, the geographical information and how to store those things on blockchain. There's not a lot of research being done about that field. Yeah? So it's of course an area that we need to look close in it, but there are not a lot of action that the knowledge is still growing to have input for the standardization.
Okay, so
yeah?
The goal of the group is really to have an open forum to discuss about that and try to anticipate and get feedbacks from early experimentations.
Sorry, and probably you talk about that before I arrived here. I was late. My question is, why do you need a blockchain and why this cannot be done in a normal database? This is because I'm struggling to understand why this thing that emerged from, virtual coins is now penetrating other fields. And maybe you can help me.
Okay. Yeah, that's always the most difficult part and the most interesting part. Yeah. Now, in the case that Joris presented it, you have a house. Yeah? You can always put that in a great central database. But who is the owner of the house? It's not the government. It's not the task of the government to store all the information, sensitive information, in for your house. Yeah? If a government stores all those things on their central database, it's got all your plumbing invoices or your electricity guide that comes along, All that sensitive information goes to the government. And which government? The Flemish government, the regional government, the federal government, the Welsh government, the local government. So you get a lot of players that give information. And I think it's very difficult to have all those players agreed that we use one central system that stores it all. You don't want that? In certain cases, you need one. So you have to transfer the identity on another phase, another system, another model. So you get this model that you put the owner in this case in first place, but in the second place, the house as an identity. And that can be given all the necessary documents and all the necessary rights. You don't claim that in the government. If you have a corrupt government, it changes your house, and you have nothing. It's maybe a silly case, but if you have, like in war, in people of Syria, as an example, they don't have nothing. The central database of buildings is gone. So how can you prove that that was your house and that all the documents that you have involved? So it is long-term, of course, but that's the main philosophy why you use it. You have very different partners who don't agree on this, and you have to have some kind of consensus. And you look at as centrally from one in the house that interacts with different things. Because if you give the house also an identity, it can do a lot of other things. If it gets input from the government, input from your energy agency, maybe it can decide and negotiate on the market your housing, your energy prices. And you get the Internet of Things aspect, that it can be negotiating and changing your energy contract, what is the most efficient thing to do. So you get a lot of things. But this is... Yeah.
It provides a neutral, I understand, it provides a neutral place where those things are stored. Nobody owns it. Even the owner of the house doesn't own the information too. It's somewhere that you do not know, in some sense, no?
No, because in the other part also, the house, you are a temporary owner. And also in the case of the nature management, that goes plans that go 30 years. Now we gave, in the first place, we gave subsidies to the owner. But the owner doesn't stay 30, 40, 50 years. But the territory and the identity of the region stays. So we get another paradigm. And maybe in the presentation of Yannick, we as a government are not the only stakeholder in that project. We have nature organization, we have farmers organization that doesn't trust each other and doesn't trust us. So you need something neutral. It was made by, put all the information in the government agency, and we got discussion. Why do you give the nature guys that subsidy? Why did you did that? And the farmers that concluded you needed transparent. So we get them in to the system, and make them controllers, and make them transparent in all.
Okay, but you're not the owner of the data, but you are the owner of the application. Who guarantees that if the test phase is out, that the application will live and I can go to my data also in future?
That is the role of the consortium. So the government doesn't own those things. We're going to transfer those systems to consortia. Consortia of different parties, organizations. In the case of the nature management plan, now we have built it, but it's going to be a system that lives in the nature organization, the farm organization, we also the big landowners corporation. So it's a shared thing. And they need to build a kind of consortium, kind of governance model that administrates the system. It's not a government thing. So in the building house of the housing pass, it's even more complex. It is a thing that will be shared with the very different parties. You have the governments involved, you have the notaries involved, the landowners involved, you have the district system. And the problem will be to have kind of business model that can be paying for those systems. And let's go back to the business model question. How do this, what economic value is in it? And what is the return model to have this thing alive and kicking? It's going to be a difficult model, but you need to figure it out. How can it be sustainable and payable? Because the government doesn't want to pay subsidy all those kind of systems for the system. The earnings are for other people, so they need to get involved in the system and need some kind of a return and economic value. So it's going to be another model. I know it that it's searching and research and a good governance model. It's going to be a different one.
Hi, Matthew Pearce from Geoscience Australia. Has there been much thought put into what happens if the ICT infrastructure that your blockchain is on disappears? So say you put it up on Amazon and for whatever reason Amazon decides to shut down their operations or that node that your or group of nodes that your blockchain's on. What happens? What happens then?
Yeah, that's a great question. But no worries. You have other partners. We are just one node, and you have multiple nodes. The other nodes will run. You share that information. So, mathematically, you see, you need at least kind of 7 nodes is the best thing that you have. If you have 1, 2, 3, 2 or 3 nodes that are out, the system will still work. In the case that you have central database and our RBS is out, everything is out. You don't work. And that gives you some kind of distributed guarantee that the system will still be working and the interfaces will be working as well. So you get some kind of...
So it's using the same sort of model as the internet, the web.
Yeah.
Yeah.
So it's called some kinds of the Web 3.0. So and we use more... You get the cloud where you can distribute things, but you distribute it over organizations, of the borders of the organization, and you get a more sustainable model. So the Bitcoin, if I make an example of the Bitcoin, you can take down the Bitcoin. You can take down a lot of nodes, but there are always nodes that have this information and can keep running. From a big server in the AWS, the AWS, to the single computer, you can be working. And that is the power also. If you lose, if you have an authentic source that goes down in a war or a terror and so on, you still have copies and you still have the information. And for the citizens, that's also important. If you need to flee your country, possibly you have not the information. Now, the people who flee the country don't have any access to the information that is. With a blockchain kind of solution, you still have in the distributed some kind of information that you can reuse and can rebuilding the system. That is a possible business model.
How scalable is the model? Because, I don't know, thinking about Bitcoin, a coin seems a very small thing. It's going to change hands lots of times, but it will not have PDFs attached, and a PDF attached is a big thing. So how scalable is that? I mean, I understand there is some kind of a replication in the system. So this is going to be big. Those are lots of houses in a whole country. So, well, that's my question.
Very interesting question, but I don't know. We don't have answers at this moment. It's going to be potentially big. You have all the houses of potential 6 million inhabitants of Flanders, attach all those people, all those things. So it's going to be a very big scalable. If this is a success, you have a problem. If you have success, that's why we don't only buy time for policy, we also buy time for technology. In 2 years, 3 years, we'll be further, and then the concept will be things. So going to production with this, anno 2018 is crazy, not going to happen, but it needs work. The scalability is an issue. The most scalable and efficient thing is the central database, of course, but you get all the other limits that we already mentioned. So it's going to be a turnover. It's a circular equilibrium between those kind of advantages and disadvantages. Okay. Other questions? Will be available. Okay, sorry.
My question is more about the social impact of technology like this, because it requires a knowledge of the topic. I imagine to explain to old people these kind of things. And also another question that I have is who is responsible for data? Because it's clear that the owner is the owner of the house. But let's put by example the owner dies. Who is responsible to update the data and check who's the next owner and responsible?
Of course, the social impact of this kind of technology is something that is very important and needs to be figured out. The most important case that Europe is going to take on our initiative is how can we transfer, give diplomas back to the students. Yeah? There are going to be some pilots in 2019 with small groups of students. How do we interact with the technology? Can they go smoothly sharing those things? How can all the change go out? So that will be a big research part, because you got a lot of people involved, a lot of people that you need to gain trust in the system. It's not going to be easy. That is research. In the other cases, that's also things that need to be figured out, how the governments work. Yeah? If you lose the key to the system, you have nothing. It stays there. It's all encrypted. You can access it with your keys, but if you lose those keys, you die in that case. What goes on? So you need to have backup scenarios where the identity, the house, can be managed by other people. So they say, a lot of examples have been mentioned, blockchain is going to be the end of the notary, the person who has kind of management of the registry. There'll always be some kind of authority that needs to be figured out to give some people some kind of relief, or if something goes bad or goes wrong, how can we change that? How can we attack that? So those are the governance questions that need to be asked before those things go even to production. Okay. Another question was,
I'm Antti, I'm the Minister of Agriculture and Forestry Finland, and of course I'm a little bit interested about how this will be funded in the long run. The development and maintenance.
Now for if you refer, I suppose you refer to the nature management case. It's an effort that is funded by the Flemish government, but we make it as open source, of course. But it would be interesting to have it more funded as a European thing, because it is about Nature 2000 policy. Every country needs that. But we see that in this particular case, the Flemish government is subsidizing this and granting this, paying for this. But in the production level, we're going to have those different organizations pay also for this. They get the gain. They always complain they don't have transparency. They have a lot of effort and overhead in doing those nature management. They have a double administration. They need to have those plans put in the system. Then they have their own system. Then they have the money they grant. They have a lot of effort. Every euro that we give, I think €0.5 is overhead, because you have a lot of going back and forth. They have to prove that the euro is spent, that the euro is spent rightly. So they can get a lot of return and value from this system. So we need to balance how that we paid for things and how they pay for it. So we need to have a governance model for that. But in first instance, because it was the first thing that going to production, we sponsored it a lot. But in other projects, we start talking about the business model in the first place. We're going to make a new thing. How do you see the partners paying for that? If there's no partner available for paying for this, we don't do it. Then it's far more easier for us to make a central system and to keep us doing this. So it's also research. Sorry that I need to answer every question that it's research, but remind the pilot, it is that the early plane, it's that phase. Okay. If there are now any more questions, we will be available at the stand of Information Flanders. I hope that's not that typical inspiring session did inspire you. And thank you for your attention and your questions. Okay.